Hello and welcome to GeneLab Chat. Today we'll be interviewing Dr. Kiss from the University of North Carolina, Greensboro. Quite a few studies already report that plants are stressed in space and that there's unique challenges needed to keep plants healthy under microgravity conditions. But filling in the knowledge gaps about this depends on the ability to conduct relevant experiments on Earth. Dr. Kiss and colleagues assessed the functionality of the random positioning machine as an analog to study phototropism in plants and found it serves well for shoot phototropism, but not for root phototropism. In this interview, Dr. Kiss describes how the GeneLab data systems and the AWGs contributed to this work. Thanks for joining us. Could you please highlight the most important finding of your study for our audience?
Yeah, well, thank you for this opportunity to meet with you and to talk about our work. So, as all of you know, microgravity is a very unique research tool, and it's sort of a precious commodity. And we've been fortunate. We've had a series of microgravity experiments on the ISS, most recently in the seedling growth project. And what we did in this study is we're also interested in looking at what I would call microgravity analogs. Some people call them simulators, but I prefer the term analog. And these instruments, such as clinostats, random positioning machines, they're really important because they allow you to perhaps confirm, extend your studies that you've done in true microgravity. And what we found in this study, which confirms other studies, is they can be good proxies for microgravity, but it really depends on the parameter that we're looking at. And in this study, in particular, as you mentioned in your opening comments, what was interesting is that the random positioning machine was quite a good proxy for true microgravity for the shoot phototropism, but not for the root phototropism. And I think we need to continue to explore options and compare true microgravity to these analogs. And that's, I think, a really unique opportunity that we summarize in this paper. Is sometimes people just do studies with the analogs, but it's really nice to be able to compare the real thing with the analog.
Thanks very much. And my second question, how did the GeneLab data systems or the AWGs help assist you in your work so you could achieve these goals?
Well, I'm a really big admirer of GeneLab because I really believe in open science, and GeneLab and NASA has been really a model, particularly for genomic data, obviously, and related kinds of data sets. So people post, the raw data from these studies, and other people could re-examine them, repackage them, look at them in terms of larger data sets. And I think the more people who use this unique data will advance science. And the GeneLab, what's nice is there actually are studies of obviously true microgravity, ISS, other platforms, but I noticed they've also been incorporating these analogs, like some data from clinostats, random positioning machines, and other kinds of instruments.
Thank you, Dr. Kiss. We appreciate the time you've spent to share this information with us and our viewers. To our audience out there, you can learn more about this work, how to join the analysis working groups, and access the data set analyzed in this work with the links provided in the description section below. Thank you and have a wonderful day.